Welcome to this explainer. We're about to fundamentally change how you understand your own vision. And honestly, we're going to start right this very second, as your eyes are taking in this information. See, every single waking moment, you're relying on a piece of biological machinery that is so staggering in its complexity, we completely take it for granted. So get ready, because we're about to break down the sheer mechanics of human sight.
We hear it all the time, right? People love to compare the eye to a biological camera, snapping little pictures of the world around us. But as we're going to see today, that analogy, it falls incredibly short of what's actually happening inside your head. Because right now, your eyes are performing a feat so extraordinary, capturing light, converting it into complex electrical signals, and assembling a seamless, full-color, three-dimensional experience, that human engineers haven't even come close to matching it. The absolute best cameras ever built by human hands still fall totally short of what your eye just does naturally, without you even having to think about it.
To really wrap our heads around this biological masterpiece, we have to start with the physical structure itself. The pure mechanics of it are absolutely fascinating.
Which brings us to Section 1, the ultimate camera and the anatomy of vision.
So when you look at an object, your cornea, that clear front surface, actually does the heavy lifting. It handles about 70% of the focusing work before the internal lens even gets involved. Meanwhile, your iris acts as this incredible dynamic aperture. Depending on where you are, it can adjust your pupil from a tiny 2 millimeters in piercing bright light all the way up to 8 millimeters when you step into a dark room. That physical expansion literally allows 16 times more light to flood in. Now, when we look at the retina, at the very back of your eye, things get really interesting. You've got two main types of photoreceptors, and just look at the contrast in these numbers. You have a relatively small number of cones, about 6 million, and these are the VIPs, handling all your color perception and fine detail. But they are entirely dwarfed by your rods. You've got roughly 120 million of them. They are extraordinarily sensitive to light, working beautifully in the dark. But here's the catch: they are completely colorblind. Let's move on to Section 2, the illusion of color. Okay, prepare to have your reality shattered just a little bit. In the actual physical world around us, there are no colors. At all. None. What actually exists out there is just electromagnetic radiation. It's just physical light waves of varying lengths bouncing off surfaces. That is the raw, unedited data of the universe. So the crucial takeaway here is that color, it's merely an illusion. It is a completely subjective interpretation that your brain actively creates when it processes those specific wavelengths. The vibrant blue of the sky, the bright red of an apple, that doesn't exist out there. It literally only exists inside your head as a biological translation. And since color is just an internal interpretation, your experience of red might actually be slightly different from my experience of red. It gets crazier too. Most of us have 3 types of cone cells to translate this light, but there's a rare condition called tetrachromacy, found in a small number of women where they possess 4 types of cone cells. Theoretically, they can distinguish colors that are totally invisible to the rest of us. Their reality is painted with hues that are completely imperceptible to a standard human eye. All right, Section 3, seeing with your brain. Which brings us to our next major revelation. You don't actually see with your eyes at all. You see with your brain. To prove this, just think about the fovea. That's the tiny, highly specialized area on your retina where your vision is sharpest. But here's the wild part. It only covers about 2 degrees of your entire visual field. Think about that for a second. Only 2 degrees of what you are looking at right now is actually being captured in high definition. So you're probably wondering, why doesn't the world look like a blurry mess with just a tiny sharp dot in the middle? Well, it's because what you experience as a seamless high-res view of the world is basically a construction. It's a best guess your brain is constantly making based on extremely limited optical data. It takes that tiny 2 degrees sharp image and actively fills in all the massive gaps using your memory, predictions, and context clues. You are basically hallucinating your reality right now based on an educated guess. Let's explore that further in Section 4, finding your blind spot. So 15. This number represents something pretty shocking about human anatomy. Right where your optic nerve connects to your retina, there are absolutely no photoreceptors, meaning every single human eye has a blind spot, a literal hole in your visual field where you are entirely blind. And we're not talking about a tiny pixel here. Your blind spot is roughly the size of 15 full moons placed side by side in the sky. It is a massive gap in your data collection. Yet, you never notice it. Why? Because your brain is always covering for you.
It takes the surrounding visual information and essentially photoshops over that hole in real time, constructing a plausible image so you never have to deal with the void. It's wild.
Now onto section 5, the limits and wonders. Despite these biological quirks, the sheer scale of what our vision can achieve is mind-blowing. Under optimal, fully dark-adapted conditions, our eyes become so unbelievably sensitive, they can detect a single photon of light. To put that into perspective, theoretically, your eye could detect the faint flicker of a candle flame from 48 kilometers. That's about 30 miles away. The engineering required to achieve that kind of biological sensitivity is just breathtaking.
Yet, when we zoom out and look at the rest of the animal kingdom, our sensory window is actually kind of narrow. We have 3 types of photoreceptors and see a specific band of light. But look at bees. They see ultraviolet light, which reveals hidden patterns on flowers completely invisible to us. And then you have the mantis shrimp, the absolute champion of the visual world, rocking a mind-boggling 16 types of photoreceptors.
The reality experienced by these creatures isn't better or worse, but it radically differs from ours. It's a deeply humbling reminder that our vision is just one specific evolutionary window. We only see the tiny slice of the universe that our biology needs us to see in order to survive.
And how exactly did we get this specific window? Well, through an incredibly long journey. From the most basic, simple light-sensitive patches on ancient organisms to the complex, extraordinary instrument you are actively using to process the light from this explainer right this second, the human eye has been rigorously tested and evolved over roughly 500 million years.
As we wrap up this explainer, I want you to consider this staggering thought. Despite all our modern technology, despite all our artificial intelligence and engineering brilliance, your own biology remains the ultimate unsolved masterpiece. No screen perfectly reproduces it, and no algorithm truly understands the sheer depth of how your brain converts bouncing radiation into the vibrant, beautiful world you experience. Which leaves us with one pretty provocative question. If the very eyes we look through every day hold such profound, mind-bending secrets, what other ordinary, everyday miracles of our own biology are we just completely taking for granted?